Hi everyone. In the last tutorial we discussed discrete random variables. In this tutorial we're going to go a step further and we're going to be looking at three different things. Firstly, how do you turn a discrete random variable into a discrete probability distribution? Secondly, what are the special characteristics of a discrete probability distribution? And thirdly, how do we draw the graph of a discrete probability distribution? The best way to start in explaining this is to look at a specific example. In this first example, we have a discrete situation. A fair coin is tossed 3 times. We're going to let x represent the number of tails obtained in 3 tosses. From this situation we can gather the data, represent the data suitably and analyse it, list the sample space and then draw up a probability distribution table. Our first step in this process is to draw a tree diagram of the situation and list all the possible outcomes. Here is an example of the tree diagram that I will draw. Each branch of the tree diagram represents a toss of a coin. Here is the first toss with the 2 outcomes being head or tails. The second branch is the second toss of the coin. And the third branch is the third toss of the coin. In each toss we can get one of 2 outcomes, head or tails. From this tree diagram I can list the sample space simply by reading the tree diagram systematically. We find that we have 8 possible outcomes. The first outcome is head, head, head. Our second outcome, head followed by a head and then a tail. Our third outcome, head, tail, then head. And our fourth outcome, head, tail and then tail. Going to the bottom half of the tree diagram, we have 4 more outcomes. Tail, head and then head. Tail, head and then tail. Tail, tail and then head. And finally, tail, tail, tail. Here are the 8 different outcomes listed. I then take these outcomes and turn it into a discrete probability distribution, and I do it this way. First of all, I determine the variable of interest. Every discrete probability situation has a variable of interest. Here, the variable that I'm interested in, the thing that I'm focusing on, is the number of tails obtained in 3 tosses of the coin. So this is my variable of interest. So what possible values could x take? If x was equal to 0, this would mean that I had no tails in 3 tosses. We have one outcome which gives us this, head, head, head. If x is equal to 1, then we have 1 tail in 3 tosses. We have 3 outcomes that give us this, head, head, tail, tail, head, tail, head, head. If x is equal to 2, we have 2 tails in 3 tosses. We have another 3 outcomes which give us this, tail, tail, head, tail, and head, tail, tail. And lastly, if x is equal to 3, then we have 3 tails in 3 tosses. We have only one outcome which gives us this, tail, tail, tail. So, where the variable of interest is the number of tails obtained in 3 tosses, then x can take 4 possible values, 0, 1, 2 or 3. We can also work out the probabilities of each value of x from the sample space. Here's a summary of the situation. We saw, when looking at our sample space and our 8 possible outcomes, that the probability of getting no tails in 3 tosses was 1 out of 8. The probability of getting 1 tail out of 3 tosses is 3 out of 8. The possibility of getting 2 tails out of 3 tosses is 3 out of 8. And finally, the probability of getting 3 tails in 3 tosses is 1 out of 8. This table is turned into a probability distribution table, which looks like this. It has 2 rows, the top row representing x, the discrete random variable, and the second row representing each of the probabilities associated with each outcome. And you can see in the top row here, I have the values that x can take, 0, 1, 2 and 3. And in the second row, I have their associated probabilities, 1/8, 3/8, 3/8 and 1/8. So what are the characteristics of a discrete probability distribution? Firstly, each probability lies in the interval from 0 to 1. So if we go back to our table here, you can see that each of our probabilities is a value between 0 and 1. There are no probabilities greater than 1, and there are no probabilities less than 0. Secondly, there is no such thing as a negative probability, and there is no probability greater than 1, as I just said. Lastly, the sum of all the probabilities in the table will be equal to 1. And this is written as sigma, probability that x is equal to x, is equal to 1. Remember, sigma is our mathematical symbol for the sum of. So this literally reads the sum of all the probabilities where x it takes on a value of x is equal to 1. And if we look back at our previous example, we will see that when I add all of these probabilities, they do add to 1. Going forward again, the final thing I want to discuss is how to draw the graph of a discrete probability distribution. This is really very easy. The graphs can be drawn either as a line graph, a column graph, or a dot graph. The most common, though, is a line graph. The discrete values of x are represented on the horizontal axis, while the probabilities that x can take are represented on the vertical axis. These graphs can either be symmetrical or skewed, depending on the situation they depict. Let's look at a graph of the situation we just looked at. You can see here on the horizontal axis, I have the values that the discrete random variable x can take, 0, 1, 2, 3. Also note that this isn't like a Cartesian plane. 0 is not at the origin here. 0 is the first value that the discrete variable can take, so it actually is placed in from the origin on the horizontal axis. On the vertical axis here, we have the probabilities that x can take. The largest probability that we have in our table is 3/8. So this is the maximum value we have up here. Our smallest value is 1/8. So we start here, go up to our maximum value, 1/8, 2/8 and 3/8. Thank you for listening.